Hello everyone, I'm Dr. Ramona Tristian and I'm Senior Lecturer in Design Engineering and Mathematics Department at Middlesex University. And we have also Professor Juan, who is also the Director of the London Digital Twin Research Center. And today we want to introduce you to like a talk as part of our research center. And the name of the talk is Seeing Double, the Future of Digital Twins. So the idea is to introduce you to the research center, to see what we are doing as part of Middlesex University and how do we involve the students, like undergraduate students and postgraduate students in the research center. And then speak with you about the digital twin, like the definition and different projects that we are running, and also looking at several digital twin use cases. So Juan, if you want to introduce the center.
Okay, good afternoon. Good afternoon, everyone. Thank you, Ramona. Yes, my name is Juan Nguyen. I am a professor of digital communication engineering and the director of the London Digital Twin Research Center, which you are seeing on the slide now. And so the center was founded in March 2020, and to oversee quite a few projects that we has been working on even before that on the digital twin. So we can come back to what is digital twin later, but this is very important and emerging technology. And so you know that the center was founded only 2 years ago, but we already doing quite a lot of research, quite a number of projects, and we have even more than 30 publications already. So the key enabling technology for the digital twin is that, okay, you know that we need to have artificial intelligence and machine learning. Also that we need to have the 3D modeling, data analytics, and a number of the other technology you can find out, like the industrial Internet of Things and so on. Okay, so the use cases or the application domain in many areas, not just a single one. Manufacturing is absolutely one of them. You heard about Industry 4, smart manufacturing, and so on. But actually, digital twin has been applied, has been developed in a number of different areas. You heard about NASA, for example. They are very advanced in digital twin technology. They simulate their spaceship and then using the digital twin concept, and also that you know that even in automotive, they want to design cars in digital domains and to test to validate things, and so many other infrastructures, so on. They have clearly that developing to see the benefit of digital twins. So not a single domain. Like even a couple of months ago, I have the important meeting with the Met Office and the National Oceanography Center, and we are discussing the possibility of developing digital twin for the environment example. So how we can make sure that we can help using the digital technology to help in the environment area. So application is plentiful. Okay, and
Okay.
Ramona, you can take over and talk in more detail, maybe about different projects. I can jump in when I see that some cover project later. Yeah.
Okay, perfect. So next we have a small video introducing the center, so that you have a better idea what we are doing.
The future is about the digital technology, about the new and advanced digital twin has been picking up pace since 2017. A lot of companies can see the potential application of the digital twin technology.
A digital twin is a computational model that is a representation of a real-world entity.
Instead of making changes to
physical system or workforce or a company operations and cause chaos if it doesn't work, we create a replica of that system in the digital world that allows us to explore those opportunities and changes and their impact before we deploy it into the real world.
The London Digital Twin Research Centre was
founded in March 2020, and before that we already been doing research
to explore digital twins in manufacturing related areas. Why would a company adopt a digital twin, and how will they justify investing into a new technology?
So the center will provide them with the technology, the validation, the demonstration of the work, and to bridge the gap between academic and the industry. So we try to develop a digital twin model of the smart factory.
So in Middlesex University we have this Festo Cyber-Physical Lab. It's an assembly line. What it does, it assembles a mock mobile device. You can collect all this data and analyze it, apply different machine learning solutions.
And that also can help you to optimize the processes, including how we can detect any potential damage, and also we can optimize the life cycle of the system.
We are trying to build a digital twin that can be adopted as a baseline by industries, that they can build their solutions on top of this one.
What we can help that, we can build the foundation, we can develop the framework, and we can do the fundamental research, and we have been working with our partner from Vietnam doing just that. We built a digital twin version of Thăng Long Bridge, which is connecting between the Nội Bài International Airport in Vietnam with the capital. That bridge has been built quite some time ago, but recently that has a lot of damage. We help them to model the digital version of that, analyzing the structure of the bridge before choosing what is the optimal solution for the repair.
When they intervened earlier on, they had a lot less problems to deal with than if they left it unattended, or they weren't even aware of those problems. And those who adopt it, they swear by saying that the benefits has been immense in terms of saving money, creating efficiency, but most of all, is driving up productivity.
So what's the difference between the conventional simulation with the digital twin technology?
Modeling existing systems, that has been around for a long time. Physical and the digital were not linked at all. We're now looking to link the two.
So it's not only a virtual representation of your physical object, it's also the interaction between the physical object and the virtual representation.
We can consider digital twins of biological phenomena such as the beating of the heart. We can also even look at socio-economic digital twins, which is trying to understand how humans and social phenomena interact with technology. And so one very good example, of course, of that is all the work that has been done in the COVID-19 pandemic.
Digital twins is like an umbrella for all these enabled technologies. So we have Internet of Things, we have machine learning, artificial intelligence. They all come together within this digital twin.
We are targeting what we call that is self-evolving, which means that the digital version needs to help the physical system to be better, how to make it smart, how to add the intelligence to the system here. And luckily now with the advance of the AI, of the machine learning, that is very much doable.
At Middlesex, we want to be delivering world-class research which actually solves problems. We want to do it from a position of ethics. Digital twin research could have potential implications for automated decision-making, for example. I would personally couch against that and say it's really important that we have humans in the loop.
The centre has its role as a research centre, but it doesn't remain just as a research centre that is reserved for a certain small group of people. The centre is there to enhance our knowledge and pass that knowledge on to our curriculum and our undergraduates and postgraduate students.
Yes, so this is just, this was an introduction to our center and what we are doing. And the last bit you've seen that what we are trying to do is to connect with the industry. So you have the industry, we have the academic research, and then we want to put this into this so-called connected curriculum, where we bring also the undergraduate and postgraduate students to work in these research projects and align the curriculum with whatever is it's required from the industry. So this short intro video gave you an idea of what is that a digital twin, and as you see, like the focus of the research center is on digital twins. So this digital twin, as it was mentioned, is like a high fidelity digital mirror of the physical entity, where the former evolves synchronously with the latter throughout their entire life cycle. So that means that you have a physical entity, then you have the digital representation of that physical entity, and then the digital twin will be these two entities communicating in a two-directional, like bidirectional way. So in the end, you have this digital twin, which consists of a virtual object representation of a real world item, in which the virtual is mapped to the physical things like in the real world, such as like it can be like equipment, it can be robots, or basically any entity or connected asset, as well as the processes involved there, because you might have what a digital twin of a process and you might not have like a digital representation of that process. So you are kind of connecting, like bridging the gap between the digital world and the physical world through this concept of digital twin. And we've seen that this digital twin can be applied across different industries. So what I want to do is to introduce you to some projects that we are currently working on as part of the London Digital Twin Research Center. And one of the projects is this one, Urban Resilience in Agriculture through Highly Automated Vertical Farming in Vietnam and in UK. So it's collaboration between the UK and Vietnam. And the project mainly addresses the challenges in sustainability issues arising from the food resilience needs. So the idea is that this project will install 2 greenhouses, one in the UK and one in Vietnam, to support this vertical farming. And we'll use this digital twin to control and monitor the production. Now, if you haven't heard of this vertical farming, it refers to the practice of growing crops in like vertically stacked layers within a controlled agricultural environment. So it aims to optimize the plant or crop growth. So the idea is to build the digital twin of this. So first step, it will be to build a 3D simulation model that is fed in real time with sensor information from the real greenhouse. And then you have this interaction between the digital model and the real greenhouse through these constant updates of information coming from the sensor data. No? So this is actually the digital twin, which is a more advanced than any kind of simulation model. It's like it takes you a step further from the simulation models. So this digital twin in the end will take into account let's say the characteristics of the crop, the variety, the environmental factors, and then you have the crop management as well, which makes it possible for the digital twin to refine the predictions more and more, and then it will make better choices for the real crops. So this is one of the students. This is one of the projects that involves undergrad students from different programs. So, for example, we have students working on this from the BEng, Electronic Engineering and Computer System Engineering programs. Then we have another project is developing connected curriculum on digital twin for health system resilience. This is a project in collaboration with Indonesia, the motivation came from what was happening at the moment now with the COVID-19. So due to the existing health crisis around the world, in Indonesia, in fact, the Ministry of Health has now included this health system strengthening as one of their top priorities. So this led to the motivation of this project that is more about knowledge transfer. So the idea is that a new curriculum with digital technologies at its core is required to upskill and train the next generation healthcare workforce, which is one of the determinants of the health system resilient framework. So this connected curriculum will help develop the next generation workforce in healthcare, and you want to prepare them to cope better with any new pandemic, if that is going to happen. No? So including the capability to use new technology as the digital twin at its core, to predict the potential upcoming adverse events, as well as any consequences that hopefully can be prevented or mitigated with the use of digital twin technology. As you can see, like, it's all about this idea of connected curriculum, where you want to align what is happening in the academia with what is happening in industry, so that you prepare better the next generation workforce. And this is what we are trying to push in Middlesex University. Another project will be this on digital twin for structural health monitoring. So we've seen over the years that there were many catastrophes, especially for bridges, that even involved human lives. So you would think, like, how can you use technology now a step further to try to prevent this kind of disasters? So we had a project on digital twin for structural health monitoring, and the focus was on the structural health of the bridges. So you want to have this continuous and long-term assessment of the operational state of the bridge, detect any structural damages, monitor the damage extent, estimate safety, reliability, simulate behaviors in extreme conditions, predict the remaining lifetime, optimize the service efficiency, and so on, guide cost-effective maintenance strategy as well. And another project I want to mention is digital twin for automation, maintenance, and monitoring in industry for smart factory. This project was in collaboration with India, so it was a UK-India collaboration, and we looked at creating a near real-time digital image of a physical process in manufacturing industry. And for this, we used our Siemens Festo Industry 4.0 cyber physical system, which we have at Middlesex University. And we created like a digital twin of this. So this is just a diagram of what we were trying to do. So on one side, you have the Festo cyber physical system, which is located at Middlesex University. And so this is the real product or physical asset, if you want. And then on the other side, we created this digital twin of this like physical assets. So this is the digital model. And then you have this interaction between these two, which gives you the overall digital twin. No? So from the real product you gather from the sensors, now using Internet of Things, you gather all this maintenance history, operational history, real-time operational data, and so on. And then you use, at the digital twin, you use some statistical models or machine learning algorithms for optimized operation that is going to be imposed on the real system or predictive maintenance and so on. So this two-way interaction between the physical world and the digital world gives you this digital twin. Now, this cyber physical system, which we have at Middlesex University, is in fact, as you've seen in the video, as well the intro video, is in fact an assembly line. No? So what it does, you have assembly production line, which is a small scale one. We don't have a full scale operational one, but it's a small scale one, which is here for academic purpose. So we use it for teaching as well. And what is happening, it will assemble a mock mobile device. So you have this conveyor belt and you have several stations. So exactly 6 stations in this. it consists of 2 islands. Yeah, so you have 3 stations for per island, and the way it works is that first of all you place an order, and then the carrier will go to the first station. At the first station, it happens the placement of lower cover of the product. After this is placed, the carrier will go to the next station where you have the placement of the PCB and fuses. Then it goes to the next station, which does the image-based inspection for accuracy. So it will check what kind of, like, how many fuses are there on the PCB, and what combination of fuses is used. Then it goes to the next station, which does the upper cover assignments. Then it goes to the next station, which does the pressure-based closing of the case. And the next one is the heat chamber-based sealant melting. So it will seal the device, and then the product is ready. An image of one of the islands is this one. So as you can see here, this is the conveyor belt, and then you have here, this is the carrier that will, and also here represented here. So you can have several carriers moving on the conveyor belt. And on this one, you see that there is a lower case placed, and then you have the PCB on top of that, and then the carrier goes to the next station, and so on. But what is important here, like for us to build the digital twin of this, is to use the input from the sensors. No? So we have this capacitive location sensor, RFID reader, and so on. So all these are used as an input into our digital model. So here is just an example of the digital twin, which is here, implemented here, and here is the real cyber physical system working. So as you can see, as the carrier is moving in real time here, you have also in the digital model is following the same movement of the carrier. And then, yeah, the carrier will stop at each station, and so on. Now, this digital model was created using Unity, and then you have the sensor information from the real CP lab are linked to the digital model, and that's the way you create this two-way, like, communication between the physical entity and the digital entity. Now, how will you use that? Well, you collect all this data, and then it will help you. You can apply different machine learning algorithms to help you do some predictive maintenance, or optimize the operation of the real CP lab. Okay, so as a motivation of why is this digital twin concept important? Well, we can have a look at some of the global digital twins market insights for 2020-2025. So up to 89% of all the Internet of Things platforms will contain some form of digital twinning capability by 2025. And digital twinning will become standard or future functionality for IoT application enablement by 2027. Over 92% of vendors recognize the need for industrial IoT APIs and platform integration with digital twinning functionality for the industrial verticals. And nearly 36% of executives across a broad spectrum of industry verticals understand the benefits of digital twinning, and 53% of them plan to incorporate within their operations by 2028. So I believe these numbers might have changed, like it might have been pushed even higher by the current pandemic, because what we've seen with what happened with the COVID-19 is that it pushed the digital transformation is like even more. So we've seen many of the industry verticals that has to go online, they had to go digital. So we've seen a boost in digital development in the past 2 or 3 years. Now there are lots of, as you can imagine, there are lots of applications of this digital twin, and then they can be applied like across the spectrum. So you can have the applications of customer experience, because customers now play a key role in influencing the strategies and decisions in any kind of business. So the ultimate aim of any organization is to gain and retain a large customer base. So integrating this digital twin can help boost the services directly offered to the customers. Another application will be the performance tuning. A digital twin helps to determine the optimal set of actions that can help maximize some of the key performance metrics, the way we've seen in these projects with Industry 4.0. Then we have digital machine building. In this case, a digital twin can be used as a digital copy of the real machine, created and developed simultaneously. So a digital twin enables simulation and testing of ideas even before the actual manufacturing begins. And once you have the manufacturing and you have the real asset, then you have the digital twin that can work in parallel with your physical asset, so that it will continuously optimize the physical asset. Then we have the healthcare as well, where you have here the digital twin can have several applications, because healthcare is kind of a wide area, no? But you can have the digital twin that can help virtualize a hospital system, for example, so that you can create this safe environment and test the impact of potential changes on the system performance. Then we have the smart cities, and I will have an example just after this slide with the digital twin of a city, that it can be used for capture the optimization of the urban sustainability, for example, or application of digital twin in maintenance. So the digital twin is capable of analyzing performance data collected over time under different conditions. So yeah, the way I was giving you the example with Industry 4.0, you can use it for predictive maintenance.
Thank you, Ramona. Can I add a couple
Yep.
of things? And actually, we didn't include in the slide here, but our work at the London Digital Twin Research Center also include one of the application is for heritage management and restoration. And that one of another project we working on with the partner from Egypt. You know, Egypt got a lot of heritage to, you know, to to manage. And so the thing is that, okay, we can use this twin to target quite a few areas, how we can apply the sensor, the IoT, even to control the temperature and to monitor situation. And nowadays, a lot of people talking about sustainability, net zero, energy efficiency, and so on. Then this twin is the right area for that. For the smart cities, I think that if you know that in Singapore, they are developing a digital twin for the whole nation, actually. And they're quite advanced with that. They work with the Dassault system. You know, Dassault system is a firm from France, and then they're working on the interconnected ecosystem of digital twins for the whole nation. So you see that is quite advanced in that. And yeah, and then like I mentioned that about the digital twin for another application for environment. And is there one European project, they're working on the digital twin for the whole of the earth. But the main application is targeting the, you know, that climate change and so on. And that also very important goals from the UK government. And that's why they are investing in digital twin for the environment. With the key thing is climate change and net zero target that everybody talking about nowadays. And so, by the way, we want to know a little bit about you as well. You're not able to talk to us, right? But you can always raise the hands and ask the questions. If you have anything, you can even ask us in between. And so I'm sorry that I have to leave now, but Ramona will go through everything with you until the end. But if you have any question for me, I'm sure that Ramona can also answer on behalf of us at the London Digital Twin Research Center. If you have any further question or want to get in touch, I'm sure that we will give you the contact later on. But I hope that you will find the remaining and the lecture and the remainings of the lecture very exciting, useful for you, and hopefully see you soon. Again, I apologize, I have to leave now. So, but Ramona will
thank
stay
you.
with
Yeah.
you.
Thank you, Juan. Yeah, so you are free to put questions there in the question and answer, and then we'll try to answer to your questions. Yeah. Thank you, Juan. Yeah, I can continue for me. Yeah, so as Juan mentioned, like we have here is just a video of this, how do they use this concept of digital twin in Singapore, because they are building the digital twin of the full city of a country.
The cooperation with Singapore is about creating this digital representation of the city in 3D so that we can 3D experience the city itself to evaluate solutions, understand how it works, and understand how it can be improved.
Singapore faces a lot of urban challenges. The researchers are trying to address some challenges through modeling and simulation. And what we want to do is to have a unified 3D models of Singapore. That's why we started the program Virtual Singapore.
It aims to synergize all the 3D efforts from various agencies of the government onto a common platform so that all public agencies can make use of a common 3D digital city model of Singapore.
It's the most significant project in the world to demonstrate the power of the 3D experience platform and the 3D experience city strategy. It's like many programs that we did in the past with industry, but it's multi-industry.
When we learn about the 3D experience platform, we have a gut feel that it has capabilities to allow us to build a virtual Singapore.
So if you look at the product innovation platform and taking that into a citywide context, the power of the platform comes from actually bringing together different types of information, different types of data.
3D Experience City can improve the life and the quality of life and planning in Singapore significantly because it creates unique data referential. And furthermore, it offers a design environment, an authoring environment in which you can simulate if-when scenarios within it.
Once you have data and you tag them into a 3D map, that allows us to visualize some of this data and spot patterns, spot trends that can actually help us, especially in Housing and Development Board. This will further improve the way that we plan and design our towns and estates.
Singapore is a city-state and there's very little room that actually we can experiment with our plans. Virtual Singapore eliminates the necessity of trying these plans out in the actual physical environment, which we have very little space.
Today, the world is fueled by massive amount of data. And moving forward, we will also take in dynamic, real-time information like IoT devices. We developed the National Science Experiment to capture the urban environmental data and allow our students to gain insights from the data collected. We can stream the data into Virtual Singapore and have it represented in the virtual world.
We're measuring temperature, pressure, humidity, light, noise levels, infrared temperature, as well as motion and counting steps. So it's really useful as an analyst to look at the data in 3D because we end up having broad questions which we can then drill down and see the details using such a platform as a Virtual Singapore platform.
We have seen a large amount of interest from other cities across the globe as to what is actually going on here in Singapore.
We're trying here with this project in particular to harmonize product, life and nature in order to arrive not only at a, let's say, smart city, but more importantly perhaps as a more sustainable, smarter living in the city.
I enjoy the frank and openness with Dassault Systems, not only with the R&D team, but with senior management at large. Dassault Systems' forward-looking and planning framework gels well with Singapore.
Dassault Systèmes has a long story of partnership from the last 30 years with many companies. But this one is with the government. This one is really to share a vision for the city for the next 50 years.
This virtual world of a city is going to be a first in the world, but it's also going to be game changer to think about the city of the future, and that's what we are doing together with Singapore.
Okay, so another example or use case of digital twin is the digital twin of the 5G network. Maybe you are aware that we have like countries that already started deploying this 5G network. And you can actually use this 5G network in two ways. So first of all, you need the 5G network to have all these high data rates to accommodate digital twin applications, no? But you also can have the digital twin of the actual 5G network. And how is that useful? Well, it is useful when you think about that deploying a 5G network now, it's quite expensive. So before actually deploying and investing in a 5G network, you can use a digital twin as a simulator, no, to simulate I don't know, the coverage area, all these parameters of your network. And after that, after you deploy the actual network, you can have the digital twin that can run in parallel with the network for optimization, continuous optimization of that network. So again, a short video on this.
The future of 5G seems limitless. Billions of mobile devices, homes, cars, even cities, all transferring massive amounts of data at blazing fast speeds with ultra-low latency. The companies that support these connected devices need a way to accurately test and validate the way their products will integrate with the network. But with 5G still only in its infancy, how do you test the real-world scenarios of a network that only currently sees a small fraction of its future usage? At Spirent, we're making testing possible by utilizing a new and agile approach, a 5G network digital twin. This emulated software replica of the 5G physical network allows for continuous prototyping, testing, and optimization across a variety of potential situations. Digital twins have been used to design and simulate the performance of everything from airplanes to cargo ships. NASA has been utilizing them for decades to simulate the harsh environments of space. With a 5G digital twin, Spirent provides designers and developers a cost-effective and flexible environment to accelerate their R&D processes and increase productivity. We can help reduce risk by safely testing what-if scenarios and cyber attacks, optimize decision-making by modeling unlimited configurations, and improve reliability by identifying design weaknesses and opportunities. 5G is the future of connectivity. Secure your place by preparing for it today. Experience imitation without limitations with a 5G network digital twin.
And I think this is the last example. We've seen that one promising solution is of this digital twin is it's used in the automotive sector. So you use this digital twin to create the virtual model of a 5G connected vehicle. So why is this useful is that, of course, we are speaking about automotive industry where you have your driverless cars. So before putting a driverless car on the real streets, you want to make sure that works perfectly. No, so you use this realistic simulator, to test all the possible scenarios of that car. So let's see this use case.
What if getting from A to B didn't involve sitting behind a wheel? What if, instead of driving ourselves, we let the car do the work? We're not talking science fiction. The cars on our roads already have a basic level of intelligence. But for our cars to do more, so that we can do more, they need to be smarter. Imagine a fully autonomous vehicle, able to make the right decisions at the right time. Journeys will be safer, they'll be more efficient, and you'll be free to focus on the things that matter most. Of course, to do that, we need to perfect the technology. Intelligent vehicles will use our most advanced technologies in new ways and will need to respond to complex driving situations, just as a human driver would. We all know how difficult it is to see the road as the sun rises, or how frustrating it is when our phone loses signal. But how do you test if an intelligent vehicle can manage these real-world scenarios? Our world-leading applied research, combined with our approach to working with industry, makes WMG the best partner to develop intelligent vehicle technology. We're working to make intelligent vehicles as affordable and usable as the cars we drive today, creating a new driving experience that all of us can enjoy. WMG's 3XT simulator for intelligent vehicles is the only simulator of its kind, designed specifically to test the real-world robustness and usability of smart, connected and autonomous vehicle technology. Our research vision is to recreate the world for an intelligent vehicle within the 3XT simulator, replicating complex driving scenarios, changing lighting conditions, communications interference or unexpected events, all in a safe and repeatable environment. Using our unique signal emulation capability, we aim to create our own wireless world, allowing us to develop next-generation communication protocols. We can replicate GPS or 4G signal loss, or even simulate a cyber attack. We will also validate sensing technologies like radar, LiDAR, cameras, and ultrasonics. 30 miles of photorealistic, real-world driving routes presented via 360-degree high-definition visuals, 3D surround sound, and real vehicle motion deliver an immersive experience for driver-in-the-loop technology evaluations. Through working with us, innovative companies will quickly learn about the real capabilities of their technology and gain a better understanding of how users interact and respond. Policymakers will be provided with early evidence against which to make informed decisions and set future standards. All this leads to reduced risk and accelerated development towards real-world trials and ultimately implementation of intelligent vehicles and technology. Our research will enable technology breakthroughs to happen more quickly, with increased confidence, bringing the benefits into all of our lives. Discover more about our research and how we can work together by visiting.
Yes, so these were some of the use cases of this digital twin. So, and you've seen through our project that we are doing at London Digital Twin Resource Center and also different use cases, you've seen that this digital twin concept have different applicability in different industries. So it's something for the future, no? So this is the direction of the technology and also of the industry, and we see that like, okay, what will be the future of this digital twin? We will have this ecosystem of digital twins, because you've seen that you have a digital twin of a car, you have the digital twin of the city, you have the digital twin of like a person, if you wish, or anything. So you have this ecosystem of digital twins, and all of these digital twins, they need to work together to form this like optimized digital world. So if you think about it, is like a system of systems, and you have all these stakeholders that they need to work together for this thing like ecosystem to work. So this is what we are kind of trying to do here in Middlesex University. We are looking at the direction of the industry, and we see that digital twin is there like to stay, and it will be, this is the direction of the technology. So we need to prepare the next generation workforce to be able to work in this environment. And what we are doing, we are trying to connect the industry with academic research and the curriculum that we are offering. Through this London Digital Twin Resource Center, we are involving undergrad and postgraduate students to work on these live research projects, and then they can gain experience, and then we have different students work from different programs working together, because you've seen this digital twin concept brings the expertise from different areas. So it's very important for to form this team working skills for our undergrads. So we have all these engineering programs like robotics and mechatronics, design engineering, electronic engineering, computer system engineering. So all these students, undergrad students will come and work together in different projects as part of the London Digital Twin Research Center. And then we have master programs as well, part of the connected curriculum, where we work together with Siemens, and yeah, we develop these modules for automation and manufacturing, and the use of digital twin in this direction. So yeah, thank you for attending this talk, and if you have any questions, please feel free to email me, or if you want to leave your questions in the question and answer chat, then it's fine. Thank you very much for attending this talk.